Now let's see this question. Draw the precedence graph for the statements S1 to S9. So one thing is, till now we have seen that these semaphores have been used to provide mutual exclusion or some kind of access control, right? And now semaphores can also be used to control the order in which process will get executed. For example, we can somehow restrict the process in such a way that they will execute in some order, right? So this is one such example. Now I'll just explain you. Now they are saying that we have S1 to S9 statements, and all these statements are can be executed parallelly in any order. So we are going to have something called as co-begin and co-end. So anything that you write between co-begin and co-end, it means that they are concurrent processes, which means they are concurrent statements. So when you have these many begin and see, co-begin, co-end, and inside it there are begin and begin and begin and begin and like this, right? So you can begin any of these statements and you can finish it off in any order. If that is the case, you are free to start any of this and you are free to choose any of the statement next one. But then using the semaphores, they have restricted the access in some manner. Just watch it. See, the semaphores are A, B, C, D, E, F, G, H, I, J, K, right? And the statements are S1 to S9. And now if you watch it, if I have to execute this statement S1, it can directly be executed. Before that, there is no need of using any. And one more thing is, they have said that they are all mutexes and all the mutexes are initialized to 0. That is one more thing, right? So all the mutexes are initialized to 0. So even S1 is free to be executed, but if you want to execute this S2, which means if you want to execute this line, S2 cannot be executed because it is trying to do down on A, and A is initialized to 0. So unless someone does up on A, you cannot do down on A successfully. Therefore, S2 cannot be executed until someone has performed the up on A. Similarly, S4 cannot be executed unless someone has performed up on C. So likewise, no statement can be executed directly. All of them are requiring some down operations, and only one statement which is definitely guaranteed to be executed is S1, right? So now S1 is going to be executed first, and after S1 got executed, watch it, we are going to do up on A and B. So when we do up on A and B, what will get enabled is, one thing is you can run S2 because it requires only down on A. So after S1, S2 can definitely be started, right? And then if you look at S3, watch it, after S1, B is also going to be enabled. Therefore, S3 is depending on B. Therefore, after S1, S3 can also be enabled, right? And now after S2 and S3 are enabled, which means after S2 and S3 are enabled, what are getting enabled? C and D are getting enabled, and moreover here G and H are getting enabled. Now let's see what are depending on C and D. So S4 and S5 are depending on C and D, right? Therefore after S2, S4 and S5 can run. S4 and S5 can run, isn't it? Watch it. Because S2 is going to enable C and D, and then S4 is depending on C and S5 is depending on D. Therefore these two can run after S2 is done, right? And now after this, after S3, if you see this, G and H are getting enabled, and what are depending on G is S6. Therefore S6 can be enabled after this, as well as H. So what is depending on H? Yes, on H, S8 is depending, right? Therefore S8 can wait for S3. Got it? But then okay, let's wait. But then S8 is even depending on P of I. We had even checked that. Okay, anyway, let's do it later. Okay, and now what about S4? Watch it. So after S4 is over, it is enabling E, and what is depending on E? On E, S7 is depending. Therefore after S4, S7 can be run, right? But then S7 is even depending on F also. Check this. S7 is even depending on F, F. And who is enabling F? F is enabled by S5. Therefore it is depending on S5 as well, right? Okay, and and then what? Yes, after S6. So let's see after S6 what happens. After S6 I is getting enabled, and who requires I? I is required by S8. Therefore S8 is depending even on this one also, right? After S6 this one, right? So you just be careful, this is a cross edge, right? Fine. And then after S6 SVI, and then after S8, let's see what happens after S8. After S8 VI, and who is depending on I? Oh, it is not I, it must be something else. Let me just check it. Yeah, it is I. Okay, so it is I, which means after this S8 I is getting enabled. Is anyone depending on I? There is no one who is depending on I, so there is no one who is depending on S8. We need not worry about it, right? And what about S7? After S7, where is S7? S7 is probably here. Yes, after S7 VK is getting enabled, and anyone is depending on VK? Yes, PK, so which is nothing but S9. So S9 is depending on S7, right? And it is also depending on PJ. So who is enabling PJ? So see who is doing VJ here. So VJ no one is doing, isn't it? Therefore it must be VJ. There must be some typing mistake there. So I feel that it should be VJ, right? Then what happens is after S8 it will get executed. I think it is VJ. Then only it is logical. Got it? Otherwise no one is going to perform any V on J, and therefore it will never get executed. That is wrong. So anyway, this is the execution of the graph, right? So one thing is they might give you such constructs, and then they might ask you the graph. Otherwise they might give you the graph, and then they will ask you such constructs. Anyway, these constructs are used long back. I don't remember the programming language name. I think it is Prolog, or I don't remember exactly, Prolog or Lisp, I don't know. But then these constructs are used very long back. And currently C programming language or Java, nothing is providing anything like this, co-begin, co-end. So the questions there, it is very unlikely that they will ask you such a question. But anyway, it is very simple, straightforward. I'll give you one or two examples so that you will understand it better. Anyway, so this question is asked in, I think, gate gate 95. This question is asked in gate 95, right? Okay.